Hello, Year 11s. I thought I'd make this quick video to help you with completing exercise 5D of the textbook while I'm away. So our learning goal is finding the rule of a quadratic equation from a table of values. So if you're given a table of values, you should be able to recognize whether the relationship is quadratic or something else. And then if it is quadratic, then find the rule that governs that relationship. So this is straight from your textbook here. And if we have a look at any of these tables that have a quadratic relationship, what you can see is that the second difference pattern is the same. So like this one here, so for y equals 2x squared minus 6x plus 1, you've got this table of values. And if you look at, say, the difference between minus 3 and 1, or minus 3 take 1, you'd get minus 4. The difference between minus 3 and minus 3 is 0. So that's the first difference, and they're all different. But then if we take a look at the difference between each of these values, you can see that they're all 4, okay? And that's what actually makes it a quadratic relationship, the fact that the second difference is the same. So with a linear equation, the first difference is the same. So if I had something like, I don't know, y equals, say, 2x, then if I created a quick table from this, x, y, 0, 1, 2, 3, I'd know that y, when x equals 0, y would be 0. When x equals 1, y would be 2, 4, 6. So you can see here the first difference, first lot of differences, this would be plus 2, 2, and 2. And that's what makes it linear, the fact that the first difference pattern is the same. If you had like a cubic equation, so something like y equals x cubed, plus or minus whatever, as long as you've got 3 as the highest power, then the third difference pattern would be the same. All right, but we're focusing on quadratics. So if you have a look at what your textbook has illustrated here, if we start with the general case, so y equals ax squared plus bx plus c, and we have x equals 0, 1, 2, 3, 4, if we just substitute each of these x values into this equation, then you have what we have is the y values in terms of a, b, or c. So for example, if you substituted x equals 0 into here, then that would just be 0, that would be 0, that would be left with c. If you substituted x equals 1, then you'd have 1 squared times a, which is just a. You'd have 1 times b, which is just b, and then c on its own, and so forth. And then if we just did this generally, we found the first difference. So if we took a plus b plus c minus c would give us a plus b. And if you did that minus this, then you get 3a plus b, etc. And now if we find the second difference, notice you're always going to get, if you do 3a plus b minus a plus b, you're going to get 2a. You're also going to get 2a here, and you're going to get 2a here. And that's really important because what it means is that whatever the difference, the second difference is, we know we can equate that to 2a. So 2a is equal to the second difference. And if we apply that to any quadratic relationship, we'll always be able to find what the a value is just by looking at the second difference. So for example, in this problem here, we've got the second difference is equal to 4. So I know that 2a is equal to 4, which means that a is equal to 2. So I know that this equation is in the form y equals 2x squared plus bx plus c. So we would just have to find b and find c. So you can easily find out what the a value is just by observing what the second difference is. and basically halving that. Now, to find B and C, first of all, to find C, it's going to be easy because we just have a look at the y-intercept. Because if you think about it, when x equals 0, if I were to plug that into any equation in this form, then this would become 0, this would become 0, and you'd just be left with C. So in this example, the C value would be -4. And then finally, to find the B value, I can just substitute any point from the table and figure it out. So let's have a look at an example on how to do this, how to find the rule of a quadratic equation from a table. So you've got exercise 5D. We'll do the first couple, and then I'll get you to do the rest of the questions. So for each of these tables, you first need to determine if the relationship is linear, quadratic, or neither. And for those relationships that are linear or quadratic, determine the rule. So for the first one, let's have a look at the difference pattern. So this one would be 12 take 5, which is 7, 21 take 12, which is 9. This would be 32 take 21, which would be 11, 13, and 15. So clearly not linear, because if it was linear, all of these numbers for the first difference pattern would be the same. Let's have a look at the second difference pattern. So we've got 9 take 7 is 2, 11 take 9 is 2, 13 take 11, 2, and 15 take 14, 2. Okay, so this is quadratic. This relationship here is quadratic because the second difference pattern is the same. So now that we have established that it is a quadratic relationship, let's find the equation in the form y equals ax squared plus bx plus c. Okay, so we know from sorry about the interruption there, year 11 is a bit of a tech issue. So as I was saying, the equation in the form y equals ax squared plus bx plus c, we can easily determine what a and c are. So remember previously we said that 2a is equal to whatever the second difference is, which in this case is 2. So we know that a is equal to 1. So I know a is equal to 1. And I know that c is just the y-intercept, which is 5, or 0, 5. So c is 5. So my equation is going to look like this. Y equals 1x squared, or just x squared, plus bx plus 5. And now to find my b value, I'm just going to substitute any point from the table. So for example, if I pick the second one here, x equals 1, y equals 12. So 12 is equal to 1 squared plus 1 times b, which is just b, plus 5. And then solving this would give me b is equal to 12 minus 1 minus 5 would give me 6. So therefore I know the equation is y equals x squared plus 6x plus 5. Okay, for question